Okay, so we're going to look at what the exhaustive search will look like, right? So when you have y here, okay, and then there are 5 predictors, and we can find the R squared values, RSQ, so the known y value, right? So let's make that absolute reference, and then the x values here. Now that gives us the R squared. Now you copy that across and you have the R squared for each of those cases. Okay, so now we have the R squared for these. I'm using transpose to get those values there. All right. And the adjusted R squared would be 1 minus, okay, so that's our n, so that should always come from there, so n minus 1 divided by n minus p minus 1, right, number of predictors, and then times 1 minus the R squared value. So that will give us the adjusted R squared. Now let's look at 2 variables at a time. So x1 and x2, x1 and x3, x1 and x4, x1 and x5, and then x2 and 3, 2 and 4, 2 and 5, 3 and 4, and 3 and 5. Right? So let's build the R squared value. So here the number of predictors is 2. All right. Okay, so now this is multiple regression. There are 2 x's and there is only 1 y. Okay, so there is no Excel function that will give you R squared directly. So I have MLR RSQ is the name of the function that MLR RSQ. Okay. If you for this to work, you should enable content when you open the file. Okay. So this is a user written macro. So when you use the y value, and the y value should always come from that, so let's make that absolute referenced, and then we have x1 and x2, okay, and then well, actually, it's easier to set it up right here so we can copy. So copy that here and there, there. Okay. Then we can build exponent x3 is there, n36, and then q36, then s36, T36, V36, yes. May have a mistake here. No, it's not SQ, then T36. V36, VW, yes. W, Z36, AC36, AF, AI36. And then you copy that and you get your adjusted R squared. Oh, there is one more here, AL36.